Hello madam, my name is Eric Yong Chen. Today I'm going to presentation scheduling algorithm. I'm come from grade 11. My group member have Chen, Wong Chin Ann, and Zhen. This is my question. Consider the following 5 processes having their arrival times, priorities, and burst time. So I need to draw the diagram and calculate waiting time and average waiting time. My topic is preemptive priority. Before I draw the diagram, I give an example in our real life similar to preemptive priority. Think about a hospital. A doctor is helping a patient with a small cold. Suddenly, a very sick patient from a car accident comes in. The doctor steps the cold patient and helps the car accident patient first. After that, the doctor goes back to the cold patient. So, this is like a preemptive priority. A higher priority task can stop a low priority task, and the low one continues later. So, let me start to draw the diagram. The first, we need to write the 0 millisecond on the front. And then we need to write out the 0 millisecond of process. The main is we need to write out P1. And then P1 equal burst time. The main is P1 equal 15. After that, I write out the priority. The priority, I use the bracket because I want to distinguish burst time and priority. And then I highlight P1 and write out P1 on the space. After 0 millisecond, next is 2 millisecond. And then I need to update the P1. 2 minus 0 is 2. 15 minus 2 is 13. So P1 need to update to 13. 2 millisecond will interrupt P2. So P2 also need to write out here. P2 equal burst time. The mean is P2 equal 5. And then priority is 1. Here I highlight P2 because P2 priority is 1. P1 priority is 4. The P2 priority is lower than P1, so I highlight P2 and write out the P2 on the space. Because the P2 burst size is already very small, so I must use the particular method to do this one. 5 plus 2 equals 7, so I write 7 on here, and then 7 minus 2 equals 5. 5 minus 5 equals 0, so I don't need to write out P2 again. And then I write out P1 equals 13 and then 4. And then I highlight P1. The space, I write P1. After 2 milliseconds, the next higher millisecond is 8. So I write 8. And then I need to update P1. 8 minus 7 is 1. 13 minus 1 is 12. And then 8 will interrupt P3. So I write P3 equal first time, P3 equal 10. And then priority is 3. So now I highlight P3 and the space I write the P3. After 8 milliseconds, the next higher millisecond is 15. And then I write P1 and then I need to update P3. 15 minus 8 is 7. 10 minus 7 is 3. So P3 equal 3. And then 15 will interrupt P4. P4 equal burst time, P4 equal 1. And then priority is 5. And then I highlight the smallest priority. The smallest priority of process is P3. After that, 15 millisecond, next is 16 millisecond. And then I write out P1, P3, P4, and P5. The reason of I write out P5 is because system will interrupt P5, so I must write out P5. And then I need to update the P3. System minus 15 is 1. And then 3 minus 1 is 2. So P3 equal 2. And then I highlight the smallest priority of process. So I highlight P5. After that, I must use the particular method to do this one. 5 plus 16 is 21. 21 minus 16 is 5. And then 5 minus 5 is equal 0. So I don't need to write again P5. And then use the same method to do this 3 process. On here, the smallest priority of process is P3. So on the space, I write out P3 and then highlight P3. And then 2 plus 21 is 23. So I don't need to write out P3 again. And then left P1 and P4. And then I highlight P1. And on the space, I write out P1. Because P1 priority is smaller than P4. And then 12 plus 33 is equal 35. And then 1 plus 35 is equal 36. So this is all about the diagram. After that, now I need to calculate the waiting time. The P1 I must use the particular method to do because here have the 3 P1 is separates. So the first is response time minus arrival time. So 0 minus 0. And then I can see the second P1's response time is 7. And then I need to use this 7 to minus the first P1 stop time. So 7 minus 2. And then same. I use the third P1 response time to minus the second P1 stop time. So 33 minus 8. So I can get 20. And then P2, because here is only one P2, so I can direct use the response time minus arrival time. 2 minus 2 equals 0. And then P3, here have two area P3. The first area P3 is continuous, and then the second area P3 is separate. So I need use the first P3 response time minus arrival time. So 8 minus 8. And then I use the second area P3 response time. The mean is 21 minus the first area P3 stop time. 16. So 21 minus 16 equal 5 milliseconds. And then P4 is easy because P4 only 1. P4 response time is 35. And then P4 arrival time is 15. So 35 minus 15 is equal 20 milliseconds. And then P5 response time is 16. And then P5 arrival time also is 16. So 16 minus 16 is equal 0 millisecond. After that, we need to calculate the average waiting time. So add up all waiting time and then divided by 5. 20 plus 0 plus 5 plus 20 plus 0 divided by 5. So 45 divided by 5 can get 9 milliseconds. So this is the conclusion. That is all for my presentation. Thank you for watching.
Hi Miss, my name is Wong Chin Ann. I will explain about non-creative shortest job first and demonstrate it using this question. Non-creative shortest job first is a scheduling algorithm that prioritize process arrive by the time with the lowest burst time. So when the arrival time is 0, there are only one process available during this time, which is process 1. Then process 1 will be executed. Since this is non-preemptive, so the process will only stop when the process is completed. So the stop time will be 15 milliseconds. So when the arrival times reach 15 milliseconds, there are 3 processes available during this time. Process 2 process 3 and process 4, and we need to choose the one with the lowest burst time, which is process 4. And the stop time will be 16 milliseconds. When the arrival time reach 16 milliseconds, there are 3 processes available: process 2, process 3, process 5. And we need to choose the one with the lowest burst time. But as you can see, there are 2 processes share the same burst time, and is the lowest burst time. And we need to, when there are 2 processes with the same burst time, we need to choose the one arrive earlier. So process 2 will be chosen since it arrived earlier. And the stop time will be 16 plus 5, which is 21 milliseconds. And then the process 5 will be chosen. And the stop time will be 26 milliseconds. And the last process that will be executed is process 3. And the stop time will be 36 milliseconds. As for waiting time, in order to get waiting time, we need to use the starting time divided with the arrival time. So for process 1, the starting time is 0, the arrival time is 0, so it will be 0. For process 2, the starting time is 16, the arrival time is 2, so the answer will be 14. For process 3, starting time is 26, the arrival time is 8, so it will be 18 milliseconds. For process 4, the starting time is 15 and the arrival time is 15, then it will be 0. For process 5, the starting time is 21 and the arrival time is 16, then it will be 5. As for average waiting time, we need to add up all the waiting times and divided by the number of process. So it will be 0 plus 14 plus 18 plus 0 plus 5 divided by 5, and it will be 37 divided by 5. The answer will be 7.4 milliseconds. That's all from me, Miss. Thank you.